All right, guys. Looks like that we are live. I'm going to give it a moment or so before it actually kicks in. Let me know if you're in the chat section here. You know, say hello or what have you. All right, so this is going to be a continuation of yesterday's little lesson, and we're going to do just slightly more, a couple more examples. We might be looking at the homework. We were looking at the, what do you say here? We're looking at this page yesterday. Let's see here. We were looking at this page yesterday. So, is that too far away? Should I zoom in a little bit? That's probably better, right? Okay, I'll try and do that. It's a little better for me. Okay, so trying to figure this out as we go. We were looking at this page, and we did those first two at the bottom section there, and we are going to continue with that. So let's go back up here. All right, so yesterday we were talking about, first off, how many people were in here? 2 people. One of them's probably me. All right, so let's see. Is this on Google Classroom? Let's see here. I'm just going to the Google Classroom right now in another tab, and it doesn't look like. All right, so yesterday. Yep, there it is. Okay, cool. All right, where are we? So, sorry about that. Just trying to work out the kinks of this thing. So, as I get better, the whole presentation will be better. Anyway, so yesterday we were talking about the 3 rules of the electron configuration of ions. And those 3 rules are as follows. We had this paper here that we were looking at. And to be stable, the first option is to be like a noble gas. That's the best option. So you would want all of your electron configurations to be ending in a P6. Okay? Now that is why all the charges I gave you going across the periodic table left to right, I said the first column was +1, then +2, and so on, all the way over to the right. Okay, so those charges I gave you a while back, they were decided based on the stability of these ions. To be stable, option number 1 is to be like a noble gas. Option number 2 would be to completely fill or empty the orbitals. That's second choice. Not as good as the first, but if you do this, you can be considered stable. And finally, the third option, the least favorable option, is to be half filled. Okay, so we did a couple options. All right, let's see who we got checking in here. We got, let's close this tab. All right, we got Anna Lee and Pat. Okay, very good. Patrick Wang. Okay, Patrick. All right, so let's see. We got, let's keep going. All right, so you should have some familiarity with the basic electron configuration. We talked about all that yesterday, all right? And then we did a couple of these guys here, all right? And what we're going to do is we're going to bring up the idea of other charges on the periodic table that we haven't talked about. So let's talk about specifically nitrogen, all right? So nitrogen is a very, very, I knew something was up there, Pat. Patrick Wang, huh? Yeah, log out, log back in. All right, anyway. So let's look at nitrogen, all right? Is this in the camera there? So, nitrogen. All right, if you look at the periodic table, we got... So I got this periodic table here, okay? I also have this periodic table that I'll be flashing on the screen a little bit. And if you notice where nitrogen is, that's element number 7. So it looks like it's going to be a 2p3, okay? 2p3. So we're going to end with 2p3 there. All right, let's do this thing here. So 2p3. So we got to go all the way up to that. So 1s2, 2s2, p3, okay? Now, having said that, we know that nitrogen is usually going to be a -3. Negative because it's a nonmetal, and they're going to gain. and it's 3 away from the nearest noble gases, so that's why it gains 3. So it goes 1s2, 2s2, p6. So that's why it's -3, and that's why I told you the charge of nitrogen was normally -3, and we just accepted that. But this is the explanation as to why, okay? Now, with that in mind, let's look at another couple of charges that nitrogen can be. Now, these are uncommon, but they're just as valid. So I'm going to slide this over a little bit and do some work over here. Nitrogen can be a +3, and it can also be a +5. Now, how I know that? Let's take a look. If I take 3 away from regular nitrogen, I'm just taking those P3s away. So I get 1s2, 2s2. There you go. Perfectly explainable based on the rules that we just talked about. All right? Now, nitrogen +5 is very common, not for us at this level, but it is valid for us. It's very stable. You take 5 away, and you just get 1s2. So everything's filled, everything's empty, and this is like a noble gas. This happens to be helium. So hopefully that makes sense, okay? Now, what's up, Matt? All right, so what we want to do, yeet. Okay, Matt, thank you. What we want to do next is kind of open this up to questions. I'm going to do another example while the delay catches up to you guys, and I want to do 1 or 2 of these from the homework packet. So if you get that out, we'll be looking at these guys here. So let's look at O-2, and then we'll do aluminum with a +3 and an aluminum with a -3. All right, hopefully this makes sense. We'll do these as examples, and again, I'm opening it up to questions right now. Okay, so let's take a look at the next one. Actually, the next one is O+2. Okay, so 1s2. Looking at the periodic table, oxygen's in this area here. It's 1 past nitrogen. So it's going to be 2s2, p4. Okay? So for it to be a +2, I got to take 2 away, and it becomes 1s2, 2s2, p2. So would you call that stable or unstable based on those rules that we talked about? Do I have them still? Here are the rules, okay? Be like a noble gas. Is that like a noble gas? No. So now we go to option number 2. Is this completely filled or empty? No. You got that P2 that's hanging around, and there's only 2 in there. Is everything half filled? Or is the, let me rephrase, is the last thing half filled? What's up, AJ? All right, so we got half filled. No. So this is not stable at all for any of the reasons that we talked about. We're going to call this one unstable. And I think that may be the first one that we've seen that's actually truly unstable. We've ranked the stability, but we've never actually called something unstable. Now, oxygen in the past we have said is definitely a -2. Let's prove it. So oxygen starts out as a 2s2p4. If I give it 2 more, that makes it a 1s2, 2s2p6. There you go. Hopefully that makes sense, and that proves to you why oxygen is going to be a stable at -2. Okay, let's check in and see how many people are online. All right, we got 6 viewers. A couple people have said hi. All right, so let's see here. Let's go to the next one. Back to the homework here. Let's look at Al with a 3+. Now, we did say that that was a 3+, meaning it gives away 3 normally. So 1s2, 2s2. And where is aluminum on the periodic table? Let's reference that for a moment. Aluminum is right here, right below boron, so it's on the 3rd row. It's going to be 3p1. Okay, that's what we need to get to. So 1s2, 2s2, p6, 3s2, p1. Now, to get aluminum to a +3, I need to take 3 away. So I take the 1 here, and I take the 2 from there. So that leaves me with a 1s2, 2s2, p6 as the final answer. This is what you would give me for, something that counts. So that looks stable to me. I would definitely call that stable based on the three rules that we keep bringing up. Now, as far as the next one goes, AL with a 3 minus, that means it gains 3. Just looking at what we started with here, I'm going to come up with the answer very quickly. Just by giving 3 electrons to that, make it a P4. Now, that doesn't appear to be stable at all, so I'm going to call this unstable. Again, all using the same rules, okay? Now, potassium is an interesting case because you could argue both of these make sense, a plus and a minus. So let's look at potassium is on the 4th row, and it comes down to 4s1. So I'm going to use the, what do you call it? The abbreviation, which is argon, all right? So since we have two that are very similar to each other, we're actually going to compare the stability of these, and we're going to decide which one, if not both, are stable, and then rank them, which one's more stable than the other, okay? So another thing, you guys, how's the audio on this? Okay, before I do this question, double check with me in the comment section that the audio is coming through loud and clear. I'm hoping that it's good. I can turn it up a little bit if need be. I'm afraid to do that without checking with you guys first. So, again, let me know about the audio. Okay, back to this question in the homework, and you're letting me know about the audio in the meantime. Okay, so potassium is 4s1 normally, right? So 4s1, that's neutral potassium. But if I take one away, it just becomes real identical to argon. So that is stable. It's just like a noble gas. Okay, thanks, guys. Audio is good. Is it better than the first one that I did on Wednesday? Like I said, I had a thing on Wednesday with the live stream, and that audio came out like garbage because I didn't have the mic actually turned on, but I was using the webcam audio. Anyway, we're not going to go much longer because I don't think there's much more I have to say. But number 13 on the homework, argon 4s1. That's for neutral potassium. If I take one away to make it a positive, I get just regular argon, okay? Now, if I give it one to make it -1, it starts out at 4s1, but it's going to become 4s2. Now you can see why I said there's an argument for this to be neutral as well, okay? And it makes sense that you can totally justify the stability of both. So let's go back to this thing. I don't know why I went to this camera. This is the one I wanted, okay? So those last two there, you could totally see why these are both stable. This one's stable because it's like a noble gas, and this one's stable because it's completely filled. Now, if I were to rank these two, I would have to refer to those 3 rules that we keep talking about. Put that back on camera. Be like a noble gas is your first choice. Completely fill or empty is your second. Half is your third. Well, the first one is like a noble gas, so that automatically is more stable. The second one is filled. That's your second choice. So this is not as stable, but it is considered stable. So that's it. That's really all I can do. I can do a couple more examples if there's any requests or specific questions, but at this point, I'm stuck with just saying that's pretty much it for the unit. There's not much more I can do. We've covered everything in the unit, and we did everything in the homework. Everything's been mentioned one way or another. But the one thing I do need to bring up is if I were to look at the view counts of the videos I've made in the past week or so, they're very low, which means not everybody has watched them. Unless you guys are having viewing parties during this coronavirus and everybody's watching it together at one person's house, which I don't see as that being okay or illegal at this point, you guys got to go back and watch those videos because these videos will totally lead up to this point and it will explain the entire homework packet. You got to watch it, okay? Like, for instance, if I go to another tab here and I take a look, I can find out how many people have watched each of these videos. I can't see who, and frankly, that's none of my business, but I can tell you how many. So let's take a look here. It takes a moment to load up. If I look at my video view counts, let's see. the video from March 24th. 10 people. Now, there's 26 of you. Okay? So that means less than half of you have even bothered to watch that video. On the 23rd, which was Monday, that was the answers to the practice test. 6 of you have watched that. So you're not really using the resources, and I'm not yelling at you. I get it, all right? But most of you are not following through with your end of the bargain here. I've been making these videos. I've been doing the best I can. There's a test coming up soon, okay? So there's got to be some sort of accountability on your end. You got to watch these videos, okay? Today's Friday. So on Monday, I'm telling you right now, I'm going to have to post some sort of meaningful assignment that will count toward your grade. It's been a little while, and I have no choice but to do that. The video before that, on the 19th, 11 people have watched that video. And that's more than a week old at this point. You could have watched that over and over. The video from the 18th, 14 people have watched that. Now, if I go back to the 17th, 25 people watched that. So that's good. And so on. My earlier videos at the very beginning, more people watched them, but then there was a huge drop-off, and I got down to 6 people on Monday's video. I don't know why I'm bothering if you're not watching. Again, I'm not yelling at you. I'm just saying. Whatever. So your job, all 7 of you that are in here right now, is to practice this stuff, get caught up. You're going to be using this time to your advantage, all right? You get to make your own schedule. These videos will be up on the thing for as long as this is going on. So watch the videos. Do the homework. Try the practice test. Monday, there will be an assignment, okay? There will be an assignment that counts. Not because I hate you, just because we have no choice. We got to make this work, okay? With that in mind, I'm going to sign off now. I've been kind of stalling to see if there's any specific questions. So far, I just got a couple highs and what have you. Yeah. All right. With that in mind, let's go back to the real world where you guys can actually do this on your own, and you have all the resources. All right. I'm going to sign off. Leave a comment with a question on the Google Classroom, and I'll get to them as best as I can. All right. All right, you guys. Thanks for watching, those who decided to, and I'll talk to you again soon. Thanks.